My name is Naren Kumar Konchada. We are doing the project Smart Movie Recommendation Systems. As mentioned above, this is my team, and since this is the deliverable 3, we are moving past the data collection and data preparation steps towards the ontology creation. So ontology creation, as basically we have what we have mentioned in the report, is the formal description of knowledge in terms of concepts within a domains and the relationship between them. So this is the overall structure of the smart movie recommendation system. So the ontology gives us the idea about what different classes are involved and how the different classes are related to one another. So for this representation of knowledge, we have used the tool called Protege. So for the first part of this video, we need to talk about how the ontology is created for individual data sets. So moving forward, so let's take the example data. Let's take the first data set of formatted IMDb. So last time when we mentioned about these are the number of columns which are involved, and for these columns, if you see the corresponding ontology that is created, then if you go to the IMDb, so this is the IMDb file data set. For this, which the ontology would be like this. So the classes, if you see, every class is a subclass of owl thing, which is a superclass. And then if you see the class, there is only one class involved in this data set, which is IMDb. And object properties would be nothing, because in this particular data set we are not having any other relations to any other classes. But data properties, there are multiple number of data properties available, which is actually the exact number of columns which are involved here. So every data set, every data property here has been given a domain and a range as well, and it has been given a sub property of all the top data property. So has duration, has IMDb rating, all of these columns have their own particular ranges and domains. So this is the first data set and the on respect to ontology. So for the second data set, so this is the data set which is from movie lens. If you see, there are all these columns involved. If you this is rating ID, movie ID, title, genre, user ID, and these two columns, which is IMDb ID and TMDb ID, which helps us in connecting with the other two data sets, which is the IMDb and TMDb. And with for respect to this, I have to talk about uh, a particular difficulty which we faced here was the movie ID and user ID are two unique things, and for that unique combination of user ID and movie ID we'll get a rating. So the problem here when you model this in ontology is we have a composite key relationship, which is a primary key. So for that to do, what we did was, in order to negate the problem, we have taken one more unique column called rating ID. So now rating ID would become a unique column which would directly map it to the rating involved here. So these are the different fields involved here. So if you go to that particular ontology and open that, so if now come here, when you go to entities here, now there are different number of classes available. IMDb ML, which is related to the IMDb, movie, rating, TMDB, ML, and a user. So now if you go ahead and see, there are object properties involved in this. If you see, the object properties has IMDb. This is basically a relation from movie to IMDb. And if you see the rating, this is just a relation between user and movie and to a rating, because both of these two domains need to be interrelated with rating. And has TMDB, obvious, it is the relation between movie and TMDB. Is watched by is movie is watched by user, so that's the relationship here. And if you go forward, data properties, there are numerous data properties involved with respect to movie and with respect to IMDb, but everything has been properly linked with the respect to range here. So this is particularly, we need to talk about the movie lens data set. Then moving forward, there is one more data set called the TMDB movies. These are the number of columns which are involved, and opening that particular data ontology here, this is the TMDB ontology. If you open here, then this is the TMDB. As I have mentioned, there is only one class in TMDB. If you go to object properties, there are none, because there are no more classes involved. The data properties again would be the each and every column. So again, everything is linked to TMDB, but the ranges are different. So all these ontologies has been created, and while saving the ontologies they have been saved in RDF/XML format. So as particularly I have to mention, there is one thing called the movie lens dataset which I have shown before. That particular dataset has a problem with the composite key, which has been removed by finding out or taking a new unique identifier called rating ID. Thank you. So this is the second part of the video, which talks about data conversion. So now we have all the data sets available in CSV format or the XML format. Now that needs to be changed to RDF format so that a SPARQL querying can be done on it, and then with different data sets can be brought together or linked together. So for this we have a tool called OpenRefine, which was suggested for our project requirement. So we picked this up because it was easy to use, and we figured out a way to upload the required file and get into the suggested or the required format. So firstly, while walking through the file, you just click on, first thing you have to do is click on choose file. So after clicking on choose files, just go to project. Now we have formatted IMDb. Just we are going with IMDb file conversion here. Click on OK, and then click on next. So the file, after the file gets uploaded, now we have a preview of what are the available columns here. You can see the IMDb ID, worlds in title, IMDb rating, etc. So now you just go on, click the create the project, and then once the project is getting created, now again you have to see you can have the preview here. And now the option available here is extension RDF. So I have to talk about this because this was not readily available with the OpenRefine tool. The extension RDF was supposed to be downloaded as an additional plugin, or you can say additional module, and then that module has to be kept inside the OpenRefine's application root folder. So after you do that and then restart the application, now this is available now. So now what you have to do is now just click on RDF and click on edit RDF skeleton. So after you do that, you just arrive at this point. Now what you have to do is click on add, because you just have to give a prefix about what your IMDb is. So just let's name it as IMDb2. Just IMDb2, and then now you just click on import and then choose a particular OWL file. Now you click on all files here. This is the OWL file for IMDb final. Click on open. Now click on OK. So now you can see that the IMDb namespace is available here. There is prefix. So you can go to the add type, and then you have to click on IMDb2. So this is available here. So now click on IMDb2. Now the properties that are associated with this have to be chosen. So click on IMDb. So now what we have is has as rating. If you click on, now you have found that rating count is available here. So now you have rating count, and then click on this and select the particular rating count available here, and then rating count is available in integer. So you select the integer, click on OK. So this process has to be applicable, or you have to be applied for all the properties which are existing here. So click on property here. Now click on property. Now you have to type another property which is for IMDb2, which is has duration. So has duration, go to this particular thing and then click on duration here, select the content, and particular duration is also an integer. So click on OK now. So this particular has duration also have been linked. In a similar way, all the properties for the existing IMDb have to be linked here, and the respective things have to be linked here, and the format also has to be mentioned. After doing this, you just click on save and then click on OK. So this the RDF schema skeleton has been saved. Now after this, you just click on export, and then click on RDF as RDF XML, because that is a format which we are looking forward for. So once you do that, the file with the respective format will be getting downloaded. So as we have already done this in our project, it should something like this. So as we have done something this for this in the project, so this is the final files which we have for all the three data files after conversion. So this is for TMDB. If you see that all the namespaces are mentioned here. And then if you go on description, this description means it's just the instance. So it's this particular file RDF file is a list of description file for all the instances. So and then if you see RDF about, this is a kind of an identifier for a particular instance. So if you see the total count which starts from 0 and see it lasts till 1000 10,865, which is our total number of instances that we have. So inside, if you go, all the properties would be listed here. Let's for example take this, and if you can see that has director property, has the name here, has tagline, has overview, vote count, runtime, and this RDF type, which is telling about what ontology it belongs to. This is the IMDb, TMDB here. So TMDB ID, cast, vote average. So all the columns from the CSV files or the Excel files would become the tag files here. Sorry for that. So moving forward, this is the TMDB, and then we have to go for formatted IMDb. This would also look the same with the list of description objects here. So after this we move forward for movies plus rating. So this is also a same in the similar manner what all we did with the same thing. We have list of description objects with the properties listed here as a list. So again, if you go down, we have 10,835 files here. So this is how we had the conversion from the CSV files or the XML files to RDF files. With the use of the OpenRefine tool and the RDF extension, we were able to achieve this. Thank you. So the next step, which is the final step in our report, is data linking. So what is data linking? So until till point at the first step, we created separated all files which denote the overall model, the knowledge representation for that particular data set. So now these particular data sets need to be linked so that we can use it for the implementation of recommendation systems in our project. That is the entire concept of semantic web between linking of different data set. So for that, then the schematic, which is the OWL files, also have to be linked. So as we have three different OWL files, these three different OWL files would be linked. So again, the tool will be coming back is to Protege tool, and in this particular Protege tool, firstly what we have to do is you just have to go to that. I'll show you the demonstration here. So when you come back to this OWL file, you just go to the active ontology, and we figured it out that there are direct import option available here. So firstly what we have to do is you just have to import all the ontologies which you want to link, which is the movie lens ontology which is mentioned here, and go down just the TMDB ontology, and this is the IMDb ontology. So these three files have to be imported here, and next what you have to do is you have to go to the entities. So in the entities, in the class tab, you just find out all the classes in all different all files available here. So this IMDb is talking about the IMDb class from the IMDb all file, and this IMDb particularly is the class from the movie lens all file. So all the files are available here. Again, in the same way, this TMDB is from TMDB all file, and this TMDB ML is from the TMDB movie lens dataset, and or the movie lens OWL file. So the way to connect all these OWL files together is, since in our project we have the only linking between the movie lens IMDb column and the IMDb column in the IMDb OWL. So what we did was just go to the IMDb ML class here, and then put this equivalent to property to the IMDb, which is from the IMDb OWL. In the similar way, we try connecting TMDB and TMDB ML both here as equivalent classes, and also there is data properties involved with that. So as these are bolded out here, the IMDb in IMDb OWL data property has been connected with IMDb ID in ML, which is the movie lens OWL. So in the same way, again here TMDB from the TMDB OWL has been connected with TMDB in the movie lens data file. So after doing this, if you see the OWL file, I just downloaded the save the OWL file. If you see, the three import statements have been mentioned here. which is this, the RDF about is the ontology or the OWL file which we are used for linking all the three, and the three import statements are from individual OWL files. And you just scroll down and see the equivalent property which connects the IMDb ML with IMDb, and similarly with TMDB for TMDB, and you go down and you can also see the equivalence class between the IMDb ML and IMDb. Here also see also the same between TMDB ML and TMDB. So this was the depiction or showing that the data files or the OWL files have been linked here, and the same explanation has been provided in the report as well. Thank you.